1994 graduate of PSU, Josh has designed everything from bridges and buildings to climbing towers and zip lines. He has a passion for the art of engineering and is somewhat of an old building junkie. His interests lie in everything from study of ancient stone masonry techniques to digital modeling and visualization, and everything in between. His presentation will be on glorified caves, and with that I'll bring him up.
This is going to be fun.
Allow me. Ready?
Well, you can touch them,
You ready?
I guess.
Go.
We're talking about glorified caves here today. You know, we all started in the same place historically. We were living in holes in the rock. And of course, being humans, we quickly became dissatisfied with that and decided that instead of accepting nature as it was, we thought probably we should modify it and make it more to our liking. So, you know, at that, come on, 20 seconds, you got to flip here.
Did flip?
Nope. Andrew.
Where's my technical guy?
See, now this is totally gonna...
Go for it.
So we started stacking stones, you know, and if you think about it, the process of stacking stones and cutting them, and at some point we thought a pattern was probably important, and it changed very little over many centuries with varying levels of success. The craft was limited. See, I don't know when you're going to flip now. The craft was limited to a select group of people. It was developed through trial and error, and it was a very limited understanding of how things work. They're not just to live in. Our creation served a purpose. The tools of the trade didn't change a lot. The shapes and forms that began to develop. We became increasingly more interested in managing our environment. So what changed? You know, in all these years, what changed? What led us to the place that we are today, which is obviously significantly different than where we were then? The answer is mathematics. You know, and so it all started out in 1638. I know that's going back a ways with Galileo, with this document, and he started talking about the strength of materials and started talking about the movement of objects mathematically, and it was the beginning of a revolution in our craft. Newton, Hooke, Euler, Bernoulli, all names that for us mean a lot, and through the 1700s it kept changing quickly. And so now we build on what we understood, not what we had done before. Mathematics became our tool. You know, and in this way, the craft of creating buildings diverged from the crafts of creating an object, in that we as engineers, we didn't make it anymore, we designed it. So what was really missing, and how does it differ from other trades? One of the things that was missing was industry. You know, specifically the creation of the steel industry really let things take off in the late 1800s. Of course, the development of rails, the development of cranes, and the desire of rural inhabitants to live in ever more dense cities really started pushing us forward in what we could and couldn't do. And of course, that whole process led to the creation of buildings and skyscrapers and vertical structures. The Flatiron Building in 1902, who would think that when this went up, and as the first tall building in New York, that it would lead to where we are today. You know, it was a combination of New World design, traditional elements still being incorporated. We had pushed things forward, but it wasn't taken off. And so how does it make our craft different? Things like this. You know, the consequences of us doing our craft wrong are failure, and failure kills people. And of course, that idea of failure became a driving force throughout the 20th century in everything that we did, and it started to influence every decision that we made, and it created a disincentive for creativity, it created a disincentive for innovation and moving forward until the digital age hit us. And now, not only can we don't have a bunch of guys in a smoky room drawing on boards, now all of a sudden we can visualize, we can envision things on a computer, and we can build them on a computer before we build them in real life. And we've minimized that fear of failure. And to a great extent, that has allowed us to really move things forward. So things like the Bird's Nest Stadium in 2008 at the Olympics, you know, we've gotten to the point where we can showcase this new aspect, where if it can be envisioned by an architect, we can find a way to build it. It doesn't matter how crazy. And so things move forward. And the big question now is, we can do anything. More important question is, should we do everything? You know, we can visualize it, we can see it. We don't use slide rules, pens, and paper anymore. It's monitors and processing power. Complexity in some ways has become a goal in and of itself, and I think there's a lot of question about whether that should be a goal in and of itself. So it's easy to forget our most important tool, which is probably the one that drives why complexity can't continue to go, and it's these guys. At the end of the day, where our craft differs is we don't make it with our own hands. We trust their hands to build what we design and what we envision. They're the true hands of the engineer. They move steel, earth, concrete. They're craftsmen in their own right. And the people in our industry who forget this are treading on very dangerous ground. You know, this is our workshop. We're not working in a garage or a studio or a factory where we control everything. We care about weather. We control about our builders' lives. Control about the physical limits of the earth and machinery around us. This drives risk, and it makes it that much harder for us to be successful at what we do. We keep pushing forward, but in spite of that, we still need to remember this. The failure is real. The most important goal in our craft is for everyone to go home safe. And for all of you not to realize the effort that goes into making that happen. We're stewards of the craft, but also the built environment. We need to remember our creations don't go on a mantle or hanging on a wall or going around your kitchen table. You know, you depend on them for your lives and you expect them to work without any question, without any doubt. We'll continue to push the envelope. We'll create whatever the minds of the architects and artists come up with, no matter how complex. We'll find a way and our tools keep improving. I don't know where we'll be in the next 20 years, but I know it should be exciting. There'll be memorable projects, and this is not mine, but it is memorable. And then, you know, in the reality of it, there are also some projects that we would rather forget. You know, just because things can be done questions whether it should be done. You know, it's limited by how much guts we have and the fundamental human need to push things forward and to become better at what we do, and to become, to do something that hasn't been done before. We're always going to make mistakes, and we always have to remember the other one, which is we're only temporary here on the earth. Mother Nature is unstoppable. It affects everything that we do in our business, and everything we create will eventually go away. You know, whether it's tsunamis, hurricanes, tornadoes, blizzards, it doesn't matter. You know, we hope to resist them. We can't forget that we don't know everything, and they're going to trick us now and then. And it's every structural engineer's worst nightmare and greatest fear. This is what keeps us awake at night. You know, some of our creations do well, and some of them don't. We learn from them, and when you think about it, these failures nowadays are what we learn from. You know, the failures of the past of we pushed too far and it fell down, that's not really what we're dealing with. We're dealing with now the battle against Mother Nature. You know, I want to be doing the kind of jobs that as a kid I'd look up at and just can't keep, you know, my eyes off of it. That's what keeps me excited. I want to build the buildings out of the sci-fi movies of my childhood, and that's what I look forward to in the development of our craft. Galileo probably would have been amazed at what we can do nowadays, and then there's other times when I'm not sure he would have been amazed or pleased with what we've come up with. He might just wonder a little bit. So with that, I want to thank you all for listening. I appreciate it, and I hope you enjoy the rest of the presentations.